Today's video is on solving and graphing inequalities. Specifically, we'll be focusing on addition and subtraction inequalities. Our first thing we're going to talk about is that we'll be using the addition property of inequality and the subtraction property of inequality. And these are going to look very similar, and they're going to go along with what we did with the addition and subtraction properties of equality. And basically what it states is that when you add the same number to each side of an inequality, it remains true. So for example, if I had the inequality 3 is less than 5, we know that 3 is less than 5. If we were to add 2 to this side and add 2 to this side, we'd have a new inequality that would still be true. And that would also be the case if we were dealing with a variable. For example, x minus 4 is greater than 6. Regardless of what x is, if you add 4 to this side of the inequality and you add 4 to this side, x would then be greater than 10. So all that's doing is just showing you that when you add the same thing to both sides, it remains true. It's not balanced like in an equation, but it does remain a true statement. The same thing will be the case with subtraction. The subtraction property of equality states that when you subtract the same number from each side of the inequality, it will remain true. And so in these examples, again, 3 is less than 5. If I subtract 2 from this, and I subtract 2 from this, then we're looking at 1 is less than 3. And again, that's still a true statement. And again, if I had an inequality like x plus 5 is greater than 10, if I was to subtract 5 from this side and subtract 5 from this side, x would be then greater than 5. It would still be a true statement. Now, going back to that, what we can also do when we're dealing with those properties is we can kind of graph our results to show what answers make it true when you're dealing with a variable, and that'll be our focus right now. So let's take a look here as we compare an equation and an inequality. With an equation, we have our 3 steps that we solve. We isolate our variable by doing the inverse operation, so we would subtract 6 to isolate that variable. Then we use the property of equality to keep both sides equal. We'd subtract 6 here, and that would tell us that m is equal to 9. Well, with this equation, there's only one answer. M is 9. That's all there is to it. As we solve an inequality, we follow very similar steps. We're going to subtract 6 to isolate our variable, leaving m on its own. But then over here, we're going to use the property of inequality, which states if I subtract 6 from this side and subtract 6 from this side, the inequality remains true. So I still get 9, but it's not m equals 9, it's m is less than or equal to 9. In the case of an inequality, there's many different solutions that make this true. We know that 5 is less than 9. We know that 2 is less than 9. Negative 4 is less than 9. So what we do is we create a number line where 9 is labeled. And because 9 is a member of my solution set, 9 is less than or equal to 9, I would shade in the 9. And then I'm going to draw an arrow pointing to the left, because every answer to the left of 9 would be part of that solution set. So with an inequality, the only additional steps really are you bring down this symbol instead of an equal sign, and then you're going to need to graph your result to show all the numbers in the solution set. I have both a addition inequality and a subtraction inequality for me to solve for you right now to show you that process again. So we would isolate our variable by subtracting 8, leaving us with just m. Then because I subtracted 8 on this side, I'm going to use my property of equality to state that I should subtract 8 on this side to keep it still the same or true. And that tells me that m is less than 4. Because I know that m cannot be 4, it's got to be less than 4. I'll still put a circle, but I won't shade in that circle. Now I'm going to think of numbers that could fall into that solution set. 2, 3, negative 4. Those are all numbers smaller than 4. So my arrow will point to the left, and that's going to show me all the members of that solution set. Here, y minus 5 is greater than or equal to 10. What I'm going to do is I'm going to isolate my variable by doing the inverse. I'm going to add 5 to get y by itself. Because I added 5 over here, I'm going to add 5 over here, and that's justified by the addition property of inequality, which states that if I add the same number to both sides of the inequality remains true. And that leaves me with y is greater than or equal to 15. So I can think of a variety of numbers that are bigger than 15, or equal to 15. 15 is equal to 15. 19 is bigger than 15. So I'm going to make my number line. I'm going to plot the 15. And in this case, I'm going to shade in the circle because 15 could be my solution. And I'm going to draw my arrow to the right, verifying that all those numbers are members of that solution set. Now, with addition and subtraction equations, we can find a lot of real-life examples we can use as examples to understand the process here. So here's a real-life example. A website offers free shipping for purchases of $75 or more. You've chosen $63.22 of items. Write, solve, and graph the solutions of an inequality that represent the additional amount of money you must spend to earn free shipping. So this is pretty typical. A lot of companies will require you to spend a certain amount of money in order to earn free shipping, and it would be sensible, if you're so close, to spend a little bit more money so you can get the free shipping. So our inequality would look like this. You'd have $63.22 that you've already spent, plus you'd need to spend some more. And that would need to be either equal to or greater than $75. So that's my inequality. Now, just like we did before, to isolate my variable, I'm going to subtract 63.22 from this side of my inequality, leave me with just x. And then I need to subtract 63.22 from this side of the inequality. Now, I like to show my work to the side, so I'm going to rewrite it again over here. $75 minus $63.22, and we're going to need to borrow in order to subtract here. And we'll have $11.78. So you must spend more than or equal to $11.78. So if I have my number line where $11.78 is, that would be a shaded in circle. And I could spend more than that. If I spent $12, that would be just fine. If I spent $40, that would be just fine. I would then have the amount that I would need in order to qualify for free shipping. All right, that's all I have for you. Thanks for sticking around till the end.